Okay, our second speaker today is not able to make it here to the conference, but he has made a recording of the presentation, and he will be live for the Q&A session. So we have Dave Catlin. He's CEO of Valiant Technology from London, United Kingdom, and his talk is titled Learning Intentions and Educational Robots. So can we have his slides, please? ขอสไลด์ขึ้นเลยนะครับ เริ่มได้เลยครับ So we need a little bit of a setup here. And Dave is actually live right now on Skype, looking at how the audience is responding to his talk. And then I think it's about 5 a.m. right now, his time, so it's very early.
Hello everyone, I'm Dave Catlin, and sorry I can't be with you, particularly because you're in Bangkok. A couple of decades ago I spent my honeymoon travelling around Thailand, so I have very warm memories of the country and I would have loved to have visited again. I'm the CEO of Valiant Technology, mechanical engineer, and since 1983, when I learnt about Sinbad, I've been designing turtle-type educational robots. So my talk is largely based upon this work and experience, and while I believe the ideas apply to all educational robots, and indeed other technologies, it needs to be confirmed by researchers with appropriate expertise. I have shipped over 250,000 robots to 30 different countries. Now I have a challenge. How do I make sure the robot is used properly and that the students get a great learning experience? I have a problem. I have no idea who will take the robot out of the box. Sometimes they're not always trained teachers, and often they don't know anything about how to use the technology. So what can I do to support them? Over the years, I've met thousands and thousands of teachers. I've worked with hundreds of them. I've visited schools on 5 different continents and done projects in some of the richest and the poorest schools on the planet. My conclusion is that success is largely based on the teacher. I've met brilliant teachers, and I've met the opposite. One teacher can take a robot and an activity and do wonderful things. Another, with the same robot, pretty much the same kids doing the same activity, fails. Why? When I've met them, I've studied good teachers. How did they manage lessons? How did they interact with the students? And for many years I've simply said, wow, I have no idea how they did that. If we could capture and bottle what they did, we would solve most educational problems overnight. I find this skill matrix useful. We have the raw teaching skills across the top and experience with robots downwards. If we are working with teachers with high skills in both, we do not have a problem. The question is, how can we help people migrate to this green quadrant? The competence ladder is another useful visual aid that applies to both teaching and technological skills. You start in complete ignorance. Eventually you end up with internalized skills. The best teachers are at this level of unconscious competence. They do things intuitively. They cannot necessarily tell you why. It's unconscious, it's just spontaneous. I want to introduce ERA, the Educational Robotic Application Principles. These summarize the value and the characteristics of educational robots. I find them a useful guide when designing robots or creating activities. And they also provide a research framework. This allows us to relate the impact of activities with, for example, a 4-year-old and compare it with different activities done by an 18-year-old. Let's look at the curriculum and assessment principle. Educational robots can facilitate teaching, learning and assessment in traditional curriculum areas by supporting good teaching practice. Like all axiomatic statements, it's very simple, but the key phrase is good teaching practice. And this paper is understanding a bit more about that phrase and how we can implement it. Isolating good practice proved a difficult task until I came across Inside the Black Box. This seminal work by Professors Black and William was first published in 2001. Now their argument is that normal testing and assessment takes a bean counter and accountant's approach. We put in these resources, all we are interested in is what we get out. In this context, the classroom is a black box. Black and William focused on what goes on inside that black box. What sort of things can a teacher do to ensure the children maximise their learning experience? It is summed up in this line: raising standards through classroom assessment. The practice of this is known as assessment for learning, AFL. Essentially, these elements codify good teaching practice. The various strands are what good constructivism teachers do, and in many cases do unconsciously. I first suggested the use of AFL and educational robots at the 2012 Teaching with Robotics conference. It offered a solution to one of the persistent questions asked by the educational robotic community. How do you implement the technology in the classroom? This paper I am presenting now is one of a series where I expand on this general thesis. I want to emphasize that despite the use of some phraseology, AFL is simply a reflection of good practice that most constructivist teachers would recognize. This is illustrated in this 1989 report on the National Turtle Project done in the UK. When you study the report, you will find a natural correspondence between what went on in the classroom and the kind of things codified by AFL. I just want to introduce the ERA engagement principle. This states that through engagement, educational robots can foster affirmative emotional states and social relationships that promote the creation of positive learning attitudes and environments which improve the quality and the depth of a student's learning experience. In general, and in plain English, kids love robots. This is a thing in our favour, but you can blow it, and I've certainly managed to do that. What I'm going to argue here is that engagement has a key role to play in establishing learning intentions. These days, reviewing information is much more than the traditional literature review. YouTube consists of many presentations by Dylan Williams and others. It includes a 2-hour BBC documentary recording an experiment where Professor William implemented AFL in a secondary school. In the UK, Teachers TV has several training videos showing AFL in action. For Teachers' Opinion, I spoke to about 20 different teachers, but I also used a particularly useful blog entitled Stop Writing the Objectives on the Board. This is from Canadian teacher cum blogger Joe Bauer, and he's certainly stirred up a hornet's nest. The blog contains teachers' opinion of all shades and colours. This study made it clear that people use a wide variety of terms as though they are interchangeable. In reality, the same term is being used to mean different things, and different terms to mean the same thing. This is a huge confusion. I want to be very clear. I will define things in a particular way, and for now I need you to suspend any meanings you may have for the words I use. I will use this Roma activity as an example. Students program Roma to go from the start, grab numbers and get them back home. There is a 2-minute time limit on Roma movement. They have to land on the number to grab it, and it needs to get home for it to add to their score. You will see here that there are several hidden strategies that the students might discover as they try and solve the problem. These are the lesson objectives for the activity. and you will notice that they're in curriculum speak. I don't know if it's due to the rising popularity of AFL or for other reasons, but it's becoming common practice to write the so-called objectives on the board. Lesson inspectors penalise teachers if they don't do this, and in some cases, students even have to write it into their notebooks. I think this joke, inspired by Gary Larson's Far Side, hits the nail on the head. To children, a lesson objective is gibberish. There's no point in writing these anyway. For a teacher and adults, there's a point in lesson objectives, but not for pupils. This is where we need to make a distinction. Learning intentions are what students think they are learning. Learning intentions are not a recitation of what the students need to do. They are focused on what the students are learning. More than that, it is what the students think they are learning. Now, many people say the teacher should negotiate the learning intention with the students, and this raises the question of how do we establish learning intentions. I founded Valiant Technology with the late Professor Tom Stonier. He always said that the role of the modern teacher was not to be the oracle of knowledge, but to be a facilitator. Now, there's nothing new about this, although he was saying it 30 years ago. The role of the modern teacher is to help students manage their learning, and I have always found that the best constructivist teachers do this. The 1967 Plowden report caught the zeitgeist of British education. By the time I got involved, it had put constructivist theory at the heart of teaching practice, but this had not always been well implemented. Teachers would set up wonderful projects, but when asked what the children were learning, it often became warm and fuzzy, and asking students sometimes showed utter confusion. I believe the uneven way theory was put into practice fuels many of the arguments put forward by anti-constructivists. Similarly, the poor implementation of AFL ideas jeopardizes an otherwise positive education initiative. This is already happening. Those dictating that you must write lesson objectives on the board, irrespective of anything, are doing it. It's a bit like painting by numbers. It has the facade of art, but lacks the spirit, and it's doomed to failure. The idea of negotiating the learning intentions with a student is often reduced to them parroting the teacher's words. Student input is zero. And Dylan Williams says creating learning intentions in an art, and certainly establishing learning intentions, can become formulaic, devoid of value. Establishing learning intentions has to be about students taking charge of their learning. The process is not about telling students what they will learn or negotiating. It is about ceding ownership. The whole trick is about engaging children. Using robots improves your chances of doing that, but you still need to work on it. What we are finding is getting students to discuss the task and use effective questioning to guide the conversation helps establish engagement, and from that it is easy to formulate learning intentions. There is a lot of research about effective questioning techniques and strategies. Particularly useful is the work of the late Professor Ted Wright, and once again Teachers TV in the UK provided me with a good source of tricks of the trade used by practicing teachers. Questioning planning is vital. You do not have to use all the questions you create, and the kids will always surprise us, but as Oscar Wilde said, spontaneity is a meticulously planned art. In the number grab activity, we start with how are you going to get the biggest score? Follow-ups might include, how do you know that will give you the biggest score? Do you think you will run out of time? Is that the right distance to move? Now, in the National Turtle project that I mentioned earlier, teachers expressed their pleasure on how robots triggered rich dialogue between the students. The point of the questions is not for you to get answers, but to spark the debate and to get students thinking. Again, your role as a teacher is to facilitate and guide if necessary. Usually the debate only takes 5 minutes or less. There comes a point where you can ask the children what they think they're going to learn. You can write the intentions on the board, but use the student's words. This slide compares objectives and student-generated learning intentions. The intentions are not academic, but they are authentic student self-expression. Of course, the teacher can guide the process and help the student clarify their thinking. Remember, the point of AFL is for the teacher to grasp what the students understand and, if necessary, change what she is doing to meet their needs. This is an early years activity. Children program Roma to deliver letters to houses. The objective is to help them understand ordinal numbers. Now, early years teachers work hard at helping students understand their learning. When a teacher asked how he knew something, one pupil told her magic. I don't think the problem is restricted to youngsters. The cited paper presents evidence that simply working with manipulatives does not mean the students grasp the embodied ideas. I think it's critical for teachers to help students understand what they are learning at all ages, and establishing learning intentions is one way of doing this. You can do a lot of activities with turtles to help students understand measurement. In this challenge, Sinbad has to travel through the desert to find some treasure, so he wants to get a tent to protect him from the hot sun. He sends out 3 teams to find tent poles, guy ropes and canvas. They each have a Roma to measure out the materials they need. When they return, they find that nothing fits together properly. The reason is that each Roma is set up with different measurement units. So when the pupils bring everything together, they see a problem. In this activity, the lesson objective is understanding the need for standard units of measurement. Establishing a learning intention at the start would remove the surprise and the educational challenge of working out why we need standard units. It's not always appropriate to start with learning intentions, and in this case you don't need one. However, it is always worthwhile helping students understand what they are learning, and you can cover this in the plenary session at the end. A valuable spacecraft has crashed. The Roma team have to design and make a structure that they can use to lift the spacecraft onto the Roma and return it to the base. There are costs for everything. The students have to find a solution that makes the most profit. The previous slide shows 18-year-old gifted math students doing the spacecraft activity. This slide shows a 13-year-old design technology class doing it, and Dr. Stephanie Holmquist received her PhD for a study of this project in a Florida elementary school. Most robot activities can be pitched for different age groups and abilities. The lesson objectives can change, and the learning intentions will reflect this and the nature of the students. The normal advice is to keep to one learning intention per lesson. Robots do not fit into that package. They are very cross-curricular and often involve multiple stages. In this Roma Scratch extension project, the students create a robot character using the design and art techniques, and then they program the Roma in Scratch and they send the program to the robot. It involves 3 different learning intentions. As soon as you implement any plan, the unexpected happens. All plans need managing. Students can always surprise you with their creativity, and the last thing you want to do is stifle their imagination. However, you have to deliver the curriculum, and it's a matter of professional judgment. Do you follow the students' inspiration, or do you nudge them back on task? What do you think they will learn? Of course, even dead ends can be valuable learning experiences. If you decide to follow their inspirations, the student will already have a learning intention in mind. What we want to find out is, it may be more work and you may need to ad lib, but the rewards can be remarkable. There is a growing literature on AFL. Certainly there are some good materials on how to formulate learning intentions. Apart from the application of the ideas to educational robots, this paper's unique contribution is its insistence that the child's role is central, in the sense that learning intentions should derive from their engagement in an activity and their perspective. in their words, about what they think they are learning. It is about them taking responsibility for their learning. So I thank you for your attention, and if Skype's working, I'm ready to answer any questions. Thank you.
Okay. Let's see if we can get Skype to work. Yes, it is working. Can you hear us, Dave?
I can, yes.
All right, you're live.
Hello, everybody.
So let me turn the camera. Okay, questions? Yes, Ivan.
Hi, Dave. This is Ivan Kalas.
I am.
I just wonder, I know you introducing several models of robots throughout these years. Do you see any progression? What is the influence on learning activities using newer models of your robots?
Say that again, please.
I'm just thinking, in the picture you showed the 3 generations of Valiant robots.
Yes.
Do you have any data which prove or show that the activities are having richer learning objectives, outcomes? What's happening at school? Is it improving with the more modern, more complex robots?
I think it's never about the technology. It's really all about what you actually do with the children and what experience they get. And, you know, we've seen remarkable things with the very simple early turtles. It doesn't need fantastic technology. Having said that, I think that we're on the cusp of a revolution in educational robots. And I may be bucking a trend here. It's not about programming. I know, you know, certainly in the UK, coding has become a big thing again. Back to the early days of Logo. It's all about interacting with the robot. How do you actually, and how does a student gain a valuable experience from interacting with the robot? With our new Roma, for example, we did a project in Maryland where they had a glove, an interactive glove, and they were able to use sign language to interact with the robot. And there's many things coming out where there's sophisticated ways of communicating with robots, more like human-computer interfaces, human-robot interfaces, and it's a matter of how we harness those interfaces in a way that helps the students have a better learning experience. I don't know if that answers your question.
Yeah, thank you.
I'd like to re-emphasize the question again, I think, because after knowing you, I think you have so much experience with producing educational robotics. So I believe that you might have some insights on where it's heading. And I'm not asking like whether or not your next version will have Bluetooth and Wi-Fi, but because now we have so much technology available with, you know, the availability of Arduinos, Raspberry Pis, and all that. Do you see that this richness in what's available as an obstacle or as an opportunity for future educational robotic kits like what you're producing?
Well, it's following on from the last answer. I mean, the robot you see, the latest robot, will work with Arduino, will work with Raspberry Pi. It already has a Bluetooth interface. So what we built is a platform. You see, the big thing about the difference between, say, Lego and something like Turtle Robots is Turtle Robots are out of the box ready. If a teacher wants to do a lot of the activities, I mean, we have literally hundreds and hundreds of activities, and a lot of them, if the teacher wants to do them, she doesn't want to spend time, 20 minutes, half an hour building a robot. She wants something that she can use within a few seconds. Now, that doesn't mean to say there's not great value. In fact, there's absolutely great value in building robots. So what we've tried to do is build a platform that the teacher can quickly, I won't say build, but modify and create a robot that has the technology in it that provides for the particular curriculum objectives she has in mind. So certainly you can fix a Raspberry Pi to our robot and run it from a Raspberry Pi program. So I see that rather than building very sophisticated robots, I think we'll end up with modular systems. We're seeing some very sophisticated robots, but a lot of them schools can't afford. I think there was some research done at Carnegie Mellon using the is it Asimov robot, the Asimov robot? Well, it cost you sort of £500,000 to buy one of those. Well, I can't imagine a primary school getting one of those. But we can, as technology becomes cheaper, we can make modular systems where people can build in the parts, add the parts to the robot they need for the way they're needing to use it. Does that make sense?
Yep. So I guess is another comment that I hope your ideas and learning intentions that you've presented today will be maybe available in some form that, because I think teachers would really benefit from the examples that you have and the principles that you've put together. So I hope there's going to be some form of a book or maybe something that people can get access to.
Well, perhaps. I mean, got a lot of work. I'm not up here at 5 o'clock just because there's a conference. I'm usually up at 5 o'clock working away, and it's just not enough hours in the day. But I thank everybody for your time and listening, and I hope it proved useful.
All right. Well, thank you, Dave. And it's very early for you, so I really appreciate it.
I didn't hear that. That was...
I really appreciate you getting up so early to present your work.
Thank you very much.
All right. Thank you.
Bye-bye, everybody.